Shopping. What's the first letter? The V. Oh, okay, yeah, no. Are we going to do that?
I think my writing is now in sync, so hopefully that's it. Okay, so I'm checking.
Nothing wrong with that. Why would you in there? I got lots of different ones. It's not bad.
And why would you say that right after
Okay. Yeah, the logo. It's not awkward. This is more than But.
Okay, are we ready? Okay. For number one, the key to differentiating trig functions is being able to rewrite. In trig, we normally like to have it like this, but in calculus, we like to derive it by bringing that power out. So we untuck it. Okay. And then this is the chain rule, because the chain rule is any function to a power, right? It's like a composition of functions with function within a function. So we have the derivative y prime would be bring the power in front, keep it the same, reduce the power by 1. Okay. Also, I am working on a chain rule song. So maybe we'll see. I might have to do it after Christmas break, but I got most of it done.
Friday.
Oh, that'd be fun. I was gonna do derivative bingo half day. So you guys get prizes. What? A normal half day, I think. Yeah, I think. It's probably, well, we didn't really get the official schedule yet. We'll find out. I don't know. Do you guys want to do derivative bingo or the song if I get it done? Because I think we'd only have time for one. Christmas trivia. Like the derivative bingo is really basic. It's like derivative 2x cubed. You know what I mean? So it's really quick. Like, so it'd be easy for you, but you just get prizes for doing derivative. You know what I mean? So it's like a little bit of math, but fun. Okay, then so we're not done yet, right? We need to take the derivative of what's inside. What's the derivative of tangent x? Secant squared. And there's nothing left. Normally we would do like the derivative of tangent is secant u prime. But what's the derivative of x? It's just 1. So it's times 1. We don't need to worry about it. So that's the chain rule. So I would erase this to the first power. My derivative is 2 tangent secant squared. Okay. Number 2, y prime here is the u is your 5x. So the derivative of tangent, if you look at your card, is secant squared u prime. So you're going to write the secant squared of the exact same quantity, 5x, right? Times what? Times? 5. Got it, right? Good. If you want to rewrite it, it would be 5 secant squared 5x. Okay, whatever. Number 3, rewrite it. Tangent of 5x squared. How many chains do we have here? 2. Chain 1 is going to be the power. Chain 2 is going to be the quantity in here. So we get y prime. This is a double chain. I'll give you a preview to my song. Chain, 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 chain rule. That's instead of chain of fools. So that's my teaser. Okay. So we get bring the 2 down, keep it exactly the same, tangent 5x, yeah? Now we have to do derivative of tangent, which is secant squared u prime. So secant squared of same quantity times derivative of what's inside secant. 5x derivative is 5. Does that make sense? Good? No.
Actually, no, figure it.
Okay. So I kept the same quantity just so you see all the varieties. So this would be like 10 tangent 5x secant squared 5x. I typically like to put parentheses around my angle just because it's very clear. You'll see it without or with, but it's just more clear when you're writing it that that's your angle. Okay, y equals tangent 5x squared. This one, this is my u is 5x squared. So y prime is secant of this same quantity, 5x squared, times what? Oh, secant squared, thank you. Secant squared, good fix, 5x squared times 10x. Boom. All right, so this would be, if you clean it up, I'm not too particular today if you clean it up, but right there, okay? So the next one is a mess. You're right. So I have, yeah, okay. Do you know the Mr. Yuck sticker?
Yes.
Do you guys know that? How many of you know that? Just show of hands. I want to make sure I'm not too old. Okay. Yeah, you put it on like poisons and it has like the poison control number. Yeah, Mr. Yuck sticker. So yeah, Mr. Yuck. Anyway, one of my friends, she was like, I don't know what that is. She's like, I don't think your students are gonna know what that is. I was like, they better know what it is. Anyway, now if you don't know it, I should get some Mr. Yuck stickers. Just stick them around. Oh, I should give them out as prizes. Put them on tests or something. If you fail, you get a Mr. Yuck sticker. So at least you get a sticker. I don't. Okay. No, I'm not that mean. Okay, let me show you the Mr. Yuck way to do this. If you don't do your algebra, the calculus is harder. But if you do your algebra, the calculus is a lot easier. So if I don't use algebra, this is a double chain. Because if I do this, I would say the derivative is secant squared u prime. So it would be secant squared of 5x quantity squared. Now watch this. Listen. If I have 5x quantity squared, what's the derivative, du or u prime? What is u prime for 5x squared? How do I take the derivative of a quantity raised to a power? Chain rule. Again, so it would be 2 times 5x to the first times 5, right? So that all goes here. So it'd be your derivative of the 5x squared would be 2 times 5x to the first times the 5. Does that make sense? So that's a mess, right? I wouldn't do that. Yeah. Let's do it the other way. I would do it this way. How can I rewrite tangent of quantity 5x squared?
25x squared.
25x squared, you guys got it. Tangent 25x squared, that's how I would do it. And then it just becomes a normal, so then the y prime would be secant squared of 25x squared times 50x. Boom. And that's the same as this. If you multiply all those, you get 50x. Okay? So, that's what I recommend. So I've warmed up your brains, hopefully, for this problem. Are you ready? Yeah. Okay. Part of being able to derive, and I think later on I'm going to do an activity where you guys will get deriver's license. Because you can show that you derive anyway. All the cheese. Okay. But being able to derive things is looking at it and knowing what rule or rules am I going to have to use. Okay, look at this with me and tell me, what do you think we're going to need to use? What are we going to need to use? Throw something out. We are going to need to use the chain rule for this dude right here, right? That's secant squared. Anytime you have a trig function squared, what else? The product rule. Does everybody see that? Look at this. Here's your product. This is your product, right? One function, 12x squared, times the other, the secant squared quantity. Yeah? So we're going to need to do product rule. We start with product rule, and then within it, we're going to have to do a chain. Okay? So are we ready to try it?
No.
Let's do it. We got it. Okay. All right, y. Let's do dy over dx. It's been a while since we said dy over dx. Okay. Product rule is first d last plus last d first. So first 12x squared, 12x to the 7th times the derivative of the last. You know what I'm going to do? I'm going to rewrite this quick. Secant of 6 minus x cubed quantity squared. I'm just going to rewrite it for my benefit. So to take the derivative of this that I've highlighted, you bring the power in front. You recopy exactly what you see in parentheses there. The secant of 6 minus x cubed quantity closed. Decrease the power by 1. So far, they've all been 2s. But if it was like 3, the power would become a 2. All right? But it's a 2, so it becomes a 1. You don't really need to write to the first power. I just did that to remind myself I did think about the chain rule. Okay? Then, the derivative of what is inside. So what's the derivative of secant u? What's that? Secant u tangent u. It's not negative, is it? Can somebody check? I don't know if I'm going to double check it before. I don't think it's negative. It's not? Okay, good. So secant u tangent u times u prime, right? Okay. So we do negative or secant of u is going to be the 6 minus x cubed. Tangent of 6 minus x cubed. What is, ladies and gents, what's my u prime? Negative 3x squared. Does it help to like write these on the side? Does that help you? That might be helpful. If not, you don't have to. But times negative 3x squared. That's your u prime. Okay. Yes. You know, I want to give a quiz before break. I still need to teach logarithms. I've been going back and forth about this. I was gonna see how you guys reacted to everything.
Reacting back.
You guys just don't want to quiz. I'm thinking we can definitely get a quiz in before break on this stuff.
Yeah.
But I don't think I want to quiz you on like throwing logarithms in. I might wait till after, but waiting until after break, like that's the thing, like then you're gonna forget it and it's gonna be even harder. So I don't know. Like I'm going back and forth. Let's see how we do. Let's keep going. Let's keep going and see how we feel after tomorrow. Maybe I'll do like a mini quiz on Thursday or something. I don't know. We'll see. We'll see. Okay. If we clean this up, you get, I don't know. Do we really have to clean it up? So you get, let's see, 72, I think, 12 times 2 times -3 is a 12 times -6 is -72. Yeah, those are my numbers.
How do you take this?
What?
You vote inside those are the things.
How do I find that those are the numbers?
Like, why are those three numbers you vote?
Because they're all multiplied. So these are the,
Take any of this.
because that is the angle, right? So I don't multiply, but what's the angle? That's not touched. It's the numbers in front, the coefficients, yeah? Okay. So then, good. Glad you asked. And then, do you see this right here? How many secants do I have of 6 minus x cubed?
2 of them.
Yeah. So I have secant squared of 6 minus x cubed. And then times the tangent of 6 minus x cubed. And then do you see I'll highlight this in another color, x to the 7th and x squared becomes x to what power? Where do I usually write x to the 9th? Yeah, by the 72. So I'm going to squeeze it in here, x to the 9th, 72. I'll clean it up a little bit. -72 x to the 9th, secant squared of the quantity 6 minus x cubed, tangent 6 minus x cubed. That, ladies and gentlemen, is our oh, no. I forgot product rule, you guys. Well, we did. This is hilarious. Okay. Think about what we just did. This is first, and all of this is the derivative of the last, right? We're almost done. So this is first d last, plus we need to do last d first. Now this one's going to be easy. This one's going to be easy. No, this one's going to be easy. Watch. I promise. Last d first is going to be easy because we did the hard part first. The last is secant squared 6 minus x cubed. What's the derivative of the first? 7 times 12 is 84. X to the 6. So we have, cleaning it up, plus 84x to the 6 secant squared 6 minus x cubed. And now we're done. We needed to use product rule. So you see how weird I can make them? I probably wouldn't put one that weird on your test.
Square it then to make it.
No, because this is secant tangent. Think of it as like each trig function is like an x versus like a y. So it's like x squared y and x squared, right? So you wouldn't combine those. Great question. Anything else? Yeah. Part of doing this is making sure you know how to use your algebra simplification with your trig functions. And it's always weird. And when we go into logarithms, it's going to be very similar to trig functions simplification wise. Okay. Let's look at this.
No.
I want you to try this. I made it easier than what I just did. Okay. Give it a shot. Start finding your derivative. You'll need to use what rule or rules? Product rule. And is there a chain rule at all?
Yeah, obviously there's a chain.
There is. With trig functions, it's when the angle is something other than x. So I have to take the chain rule with that sine 3x. Does that make sense? Normally, it's like a function to a power if it's a polynomial or radical. But remember I told you, I taught you how to derive those trig functions way early on, and you were using chain rule without knowing you were using chain rule. That's what this is, the sine 3x. Give it a shot. I'll be around. So here's your f prime. You do first, d last, which is 1 minus, okay, sine of u. The derivative is cosine u prime. So it's cosine of 3x times I don't need those parentheses. U prime. What's U prime?
So,
The derivative of 3x was 3.
good work.
Okay. So sometimes it's helpful to write U is 3x, U prime is 3. Okay, if that helps. So that's first D last. It's helpful to write what you've done. Then I need to do plus last D first. Now, if your first part is the hardest one, the next part's going to be easy. Okay, unless it's a challenge problem. Okay, so then we have the, which I might give for like bonus or something. Huh?
I'm taking 17 minutes.
17 bonus points. Not to make you do work for like 4 pages long or something. So this is last D first. Actually, I had a professor one time, she assigned this like extra credit, and it took me like, I mean, I had like 4 pages of writing for this stupid problem. I mean, it was insane. And the answer was 0. The answer was 0. And I was like, are you kidding me? It was insane. It was for differential equations. That's like Calc 1, 2, and 3 become the algebra for differential equations.
Wait, what class was this?
Differential equations. Yeah. It was fun though. Her name was Professor Alexander.
It was fun doing 4 pages.
I mean, that wasn't fun. I was annoyed that the answer was 0, but it was an experience. It was an immersive experience. It made me a better math person. Okay, so be thankful. There's always something to be thankful for. That's my point, right? I'm not making you do 4 pages. I'm just making you do like, you know, a line across page. Okay, clean it up, clean it up. We got everybody do your share. So how do we want to clean this up? We could one. Okay, so we have like your 3 in front of the cosine. 1 minus 3 cosine 3x. Does that make sense? I want to clean that up. I shouldn't leave constants out the side. 2 times, I could, do you guys want to distribute?
2 parentheses x minus 1, and not 2x minus 1. Why'd you like stuff like
I didn't mean to do that. Thank you. Good call. Okay. So then look, I'm going to distribute the 2 here. So I get 2x minus 2 sine 3x. Good. And you could foil this out, but do we really want to do that? Nah, that's fine. Okay. All right. The last one, you can make it fairly easy. Take a look at this. Are you ready to move on?
Yes.
Was anybody copying? Here's that if you need it. Take a look at your next example.
Wait, I have a question.
F of x is sine squared 2x over cosine squared 2x. Oh, you have a question for the last one?
Yeah.
Yep.
What about that 3 that you put on the outside of the 1 minus? Oh, you just.
So, yeah, I know that's weird. This 3 only goes to, it's like, it's not distributed to that quantity because I'm taking the derivative of, that's a great question. Do you see it now? It's just times that cosine 3x. Yeah, it's within it. It's not on the outside of it. Yeah, it might be helpful if I did like brackets, if I made that like a bracket to differentiate between that. Differentiate. All right, yeah. All right, so how would you handle this? What could we do? We could use quotient rule, but that's the lame way. It's the long way. We can simplify how? Remember what I taught you in trig?
So. Wait, cosine.
Who has it?
Squared is.
It's we have a winner. So I would simplify this. You guys remember tangent x is sine over cosine, right? So tangent squared is sine squared over cosine squared of 2x, right? I would rewrite that as, I'm gonna untuck that square. So I'm gonna make it the tangent of the quantity squared. Ladies and gents, it helps me, look, whenever I have any angle other than x, do you see I have a 2x?
Yes.
That's gonna be another chain. So I like to put parentheses around it. So this is our double chain, not a big deal. This is much easier compared to the last one. F prime. Go ahead and write out what you think it is. Go. Our last one for instance, and then I'll let you practice.
Oh my gosh, it's not bad. Like, what are we doing? But what?
I think that one over there is broken. So this one? Okay, here's your derivative. Bring the 2 in front. Becomes the tangent of 2x to the first times the derivative of what's inside. The derivative of tangent u secant squared of u prime. Secant squared of u is 2x. U prime is 2. Seeing some nods? So, final answer 4 times the tangent of 2x secant squared of 2x.
No, stop, bro. Yeah, okay.
All right?
Yeah. But on the last year, you almost.
Yes.
So how comes on the last one, that 3 stayed with the cosine, but that 2 doesn't stay with the secant?
Do you see that this is all multiplied? So the 2, I can just write anything in whatever order for commutative property for multiplication. Oh, up here, this was subtracted. So the 3 is only goes with what it's multiplied to, right? So this is like, I can write this as, you know, like 1 minus the cosine of 3x times 3 is just 1 minus 3 cosine 3x. There we go. Yeah. Okay. I know, it's so weird, so laggy. Good? Okay. All right. What should we do for homework? You do need to practice this. So, ladies and gents, here's homework. Okay. I do have 12 problems here, but I also know these take a while, right? So I'm willing to make a Friday deal. How about
Odds or even? Flip a coin.
flip a coin for odds or even? No, actually, you know what? I think I know what I want you to do. I want you to do the evens because number 12, look at number 12. You need to know how to do that question because some of you missed that on the last quiz. Okay? Well, most of us got it, but it's a good refresher. Okay? So homework tonight is the evens. Even Steven. If you feel like you need extra practice, then you can do all of them at some point, maybe not even tonight, but maybe you just, I need to come back to this, revisit it, then you'll have extra practice, okay? And my answer key, I think it's uploaded. I'll double check, okay? Go. What did you ask? What did you ask?
Oh, I was